Hello everyone, I'm back with a new video for you. I purchased this Dehua DVR for my home office and it is a 4 channel X265 video recorder. The model number is DHXVR4B04 and as soon as I took it apart to put in the hard drive, I noticed a flaw in the PCB and I will show you what the flaw is. This is the whole motherboard of the DVR. This is the processor and this is the RAM and this is the, I think this is the encoder. It is a proprietary chip and I think this is the video encoding chip. And can you see anything unusual in this PCB? Well, as you might have guessed, there is no capacitor in this PCB except this tiny one at the power input, and other than that there is no capacitor in that PCB. Today I'll tell you why these capacitors are necessary in this motherboard and what problems could be caused by omitting them, and also I'll tell you why these chips need heatsink and how to rectify these problems without voiding the 2-year warranty of this DVR. So let's get started with it. To help you understand the real function of a capacitor in a motherboard like this, we will first take the example of a real computer motherboard. This is a computer motherboard and you can see these are all capacitors. These are solid state capacitors. This part is the VRM or voltage regulator module of the motherboard and the entire system. This part supplies regulated voltage to the processor. These are MOSFETs that actually regulate the voltage with the help of a controller IC like this and supplies it to the CPU. In order to do that, these are the chokes. These are chokes or inductors and these are capacitors. In order to do a precise voltage regulation, you need chokes and capacitors to do a precise voltage regulation. Without them, the voltage regulation might not be precise, and in this case, in the case of a computer motherboard, there will be no output voltage at all without a capacitor. And this is the voltage regulation module of the RAMs. And you can see there are very many capacitors in this part. So in this DVR, it is a similar system. This is the CPU, this is the hardware encoder. This is the RAM, it's a 128 megabyte RAM. And I have looked up the specs. It's a 128 megabyte RAM. It's a Nanya N7 NT55C 128M chip, and you can look that up in the internet too. And this CPU is the DRB CV400 chip, and this chip, it's a proprietary chip. I am not entirely sure what its function is because you cannot get any datasheet for that, but I am thinking it could be a hardware encoder because it is located near the camera inputs. So let's plug in the system to the power, and with the help of my multimeter, we'll try to find out what these missing capacitors were designed to be functioned for. Let's get started with this also. But before I do that, I'll debrief you on the function of a capacitor. At least the function which is needed for this part. This is the switching power supply which they shaped with the DVR system. So to show you the function of a capacitor in a system like this, first let me give you the example of a linear voltage regulator or a linear power adapter like this. This is a switching power adapter. This is much more complicated then a linear power adapter. But today I'll be explaining linear power adapters to you for the sake of simplicity. When you plug it into the wall socket, you input 220 or 110 volts into a transformer. You input this into a transformer. It's a step down transformer. You input 220 volt AC or 110 volts as it is the case into a step down transformer. But mind you, when the output you get a lower voltage, for example 12 volt, but mind you it is AC. But systems like this, these all operate in DC voltage. So now we convert this 12 volt AC into 12 volt DC using a diode bridge like this. The 12 volt AC, the 12 volt AC is inputted into a diode bridge like this, and we get 12 volt DC. But this 12 volt AC has a waveform that looks like this. Now mind you that these peaks are not at 12 volt but they are actually at 16 volts, but I am using 12 volt for simplicity. But this 12 volt DC after rectification, full wave, after a full wave rectification, this 12 volt DC looks like this. But a pure DC signal looks like this. This 12 volt DC signal has ripples because it has been converted from an AC signal. So this ripple can damage sensitive circuits like these, sensitive equipments like this CPU, this RAM. It can damage things, and another thing that is most affected by fluctuations and ripples is the hard drive. So how do capacitors work to eliminate or reduce these ripples?
A capacitor is like a tiny battery.
The only difference is that a battery stores the electric charge in a chemical energy, but a capacitor stores it in electrical energy itself. And because of this difference, a battery can be recharged only a limited number of times, like 500 to 1000 times, but a capacitor can literally be charged and discharged in finite times. So this is a capacitor. This is a polarized capacitor. Now we input rippling 12 volt DC into it. With ripples. Now when it is connected parallel to a circuit, what it does is for the sake of simplicity, I have always told this is 12 volt, but this is not actually 12 volt, it is 16 volts. The peak is 16 volts. The 12 volt is the root mean square. Root mean square of 0 volt and 12 volt. Root mean square of 0 to 12 volt, of 0 to 16 volt is 12 volt. And when the capacitor, when you feed the capacitor 0 volt, the capacitor is discharged at this point. Now when the signal goes up, the capacitor starts to charge. At this point the capacitor charges. Capacitor charges to 16 volt at this peak. And when the signal goes up, the capacitor releases its charge. And because the capacitor releases the charge, the voltage does not drop. The capacitor charges at this point till this point, and when it releases the charge, the voltage does not drop as much. The voltage only drops to a little below 16 volts, thus eliminating so huge ripples into softer ripples like this. And if you use a large enough capacitor, theoretically you could eliminate these ripples into a pure DC signal like this. But mind you, this DC signal will not be 12 volt, it will be 16 volts because it is charged at the peak. It will always show the peak voltage. So this is why a capacitor is necessary. So let's try to find out what are the roles of these capacitors. So I have plugged in the power supply and let's check the output. Since this is a switching power supply, the output is fixed to 12 volt. I will show you the case of a linear power supply that I have. Let's check the output of a linear power supply. See, as I told you, the output is a little above 16 volts. It is because the transformer is appropriately oversized to compensate the load, and since this is a switching power supply, they have already regulated the voltage to 12 volts. Now let's put it in. Let's power this thing. Now we come to the case of this missing capacitor 1. What should be the voltage at this capacitor? This is 12 volts, and this missing capacitor 2, it's 5 volt. So it is clear that because it is situated near the hard disk power supply area, these capacitors were supposed to reduce the ripple current and the interference and voltage fluctuations for my poor hard drive. But without them, this hard drive is going to suffer. I'm also not letting go of the evidence that might be caused by a corrupted hard drive caused by ripples, voltage fluctuations. This is the hard drive output. This should be 5 volts, yeah, and this should be 12 volts. So those capacitors were definitely for the hard drive. And let's see the missing capacitor number 3. This is situated near the RAM. This is supposed to be an SMD aluminum electrolytic capacitor, or I think it should have been a solid state capacitor. This should be for the RAM itself. Yeah, as I guessed, it is a 1.5 volt supply. So this is for the DDR3 RAM. This is a DDR3 128 meg RAM, and this capacitor was supposed to protect the RAM, and they have omitted that too, shameless fellows. And there is also missing capacitor number 4. It is situated near the USB ports, and I think it should be 5 volts. I think it should be. Yeah, as I guessed, it is a 5 volt channel, and it should have been protecting the USB drives or mouse which you should be plugging in, but they have also omitted that too. So what can I do right now? I will use these capacitors. This is a 2200 microfarad 16 volt capacitor. A capacitor voltage should always be rated higher than the supply voltage at which you should be fixing, and 2200 microfarad should be enough. And switching power supplies usually need tantalum capacitors like this, but I think for this demonstration I will use electrolytic capacitors. So, and I have another capacitor. It's 1000 microfarad 35 volt. I will put the 35 volt capacitor in the 12 volt line just like this. I will just push it in. That way I'm not also voiding the warranty, but at the same time protecting the hard drive. But if I solder capacitors in there, I am definitely voiding the warranty. That goes without saying. But this will not void the warranty, because whenever there is a defect, you can just pull out the capacitors and send it out for RMA. And the USB part, well, unfortunately I cannot add any capacitor in there, because also I could add external capacitor you know, with a male USB. You could add that, but for the RAM, well, it's SOL. It's definitely out of luck, because soldering a capacitor in here will void the warranty. I'm not going to do that. And about this chip and why this chip needs heatsink, now let's get to that. I will tell you why this chip definitely needs a heatsink. Now let's run this DVR with one camera attached for a few minutes, and let's see how much it heats up.
Now let's run this thing for quite some time, and here I have my infrared thermometer ready. My infrared thermometer is ready to measure the temperature after quite some time. The sensor is here. I'll try measuring it after some time. So 5 minutes have elapsed since I started running this machine. So let's try checking the temperature of the CPU itself. The CPU is at 60 degrees, and the temperature of the encoder chip now this encoder chip is at 76 degrees, and that too with the box open. It is running for just 5 minutes and with only one camera. Now imagine what will happen when the lid is closed and there are 4 cameras and it is running 24/7, and these kind of sustained temperatures is definitely not good for any silicon chips. So this temperature is almost at 80 degrees, and the CPU is at 65, and the RAM, it is at 53. It's not a problem. So how to rectify this problem? So I purchased these heat sinks for Raspberry Pi for $1, less than $1 a pair. It's 50 rupees a pair, and we can affix these to a pair. And the specialty of these is they come with two-way sticker beneath, so we don't have to use any thermal adhesives and void the warranty. So let's try to affix the heatsink. First we'll clean the chips surface. These stickers are supposed to be thermally conductive. There we go. It has been affixed. For this chip we'll use the smaller heatsink. There, it's done, and the day is saved. So if you like the video, please like and subscribe to my channel, and as always, thanks for watching.